Alright, I ran over in my last video, so I had to make a part 2 and just have to do the very last problem. Alright, so, at the right is a free body diagram for a cart. All forces have been drawn to scale. In the space below, sketch the cart, rope, etc. as they would appear in the laboratory. So here, we've got a table, a cart, and a rope pulling it. So according to this free body diagram, it's got a little bit of both an X component and a Y component. And according to this free body diagram, the Y components here should add up to this weight, so there should be no vertical movement. Really just looking at seeing what's going on with the X component, or the X-axis movement. Now, what can you say about the motion of the cart based on the free body diagram? For example, could the cart be moving to the left, moving to the right, stationary, etc.? So in this scenario, the big question is there any friction? That's really what will dictate this, and what's the coefficient of friction? So let's say there is no friction. The cart would definitely, absolutely be accelerating to the right. However, yeah, and that could be the case even if there is friction. It just depends on the coefficient and the value of just whatever the magnitude of that friction. And if the magnitude of that friction is greater than or equal to this tension force, then I would say, well, it would be equal to, I should say. It would never be greater than, because then it would be, well, it could be greater than. But in that scenario, it would be moving but decelerating. Like it'd be moving in the positive direction. However, the acceleration would be in the negative direction, so it'd be moving towards a zero velocity. But I do want to say, so most likely it's either accelerating to the right, or we're looking at a cart that is stationary or moving at a constant speed. And if it's stationary or a constant speed, of course, there is zero net force, meaning there would be a X component, a negative X component of friction here. And that's really it. Well, yeah, I do want to touch on the negative acceleration again. So if there is a large friction component, it could be greater than this tension. So the only way that would exist is if the cart had been moving already, and then there's just less tension being applied, and the friction force would just start slowing it down until it became equal to this tension, and then we'd be looking at a zero net force and zero acceleration. Yeah, that's it. I hope you enjoyed. Sorry I had to go into 2 videos.